So let's talk about compensation. So to run compensation on an image file, you will first need to acquire single color controls. So just like for flow cytometry, you want to acquire single color controls that are reflective of your experiment. So in my case, I did a 10 color confocal microscopy experiment. So I prepared 10 single color compensation sets of compensation images. What I like to use are these ultra-comp E beads for generating the compensation matrix and the compensation images, because they're a lot easier to handle. So in my case, if I have 10 colors, I don't want to stain 10 different tissue samples and image those. I'd rather stain 10 sets of beads, and I can actually do this all on one slide by actually going and drawing with a pap pen 10 individual circles, and then each circle will have compensation beads that were stained with one of the 10 colors. So one color per one circle is the goal. Now when I image the beads, I also first I will go under the microscope, find my tissue of interest that I want to actually perform microscopy on, set up my settings, and be at the on the objective that I want to use for my final imaging experiment and everything. So everything's set up exactly as I want to image, and only then will I switch to the compensation bead. Because if you, for example, are on a 20x instead of the 63x objective that you will actually end up imaging at, that will change your settings, and if you have different settings, then your compensation is not relevant to your actual final images. So you really need the same exact settings on your compensation beads as you have on your actual microscopy images. So that's why I set up everything on my tissue and only then switch to the comp bead. And so just like for the actual images, if you have a 10 color image, you need 10 colors on your compensation, so you need to acquire all 10, and you need one compensation bead stained with one color for each of the 10 colors. So for example, this is BV421 stained beads, so you can see the round beads, and they're very bright. Now because I have all 10 colors on one slide with the different colors in different pap pen circles, what can sometimes happen is when I put on the cover slip, the beads move around. And so this is the AF488 channel that I'm looking at right here. So these are how small the beads are. This is a 63x objective, and they're still tiny, so they can be kind of hard to find if you are, for example, imaging on a 10x objective. That might be a little difficult, but on a 2040 or 63x you will find the comp beads, and I've done this on the epifluorescence microscope as well as the confocal. So here are the AF48, but we also have this comp bead here, that's the same with a different color, this comp bead here, that's the same with a different color. So you can see they mix together, and for that, for us, that's going to be a problem for generating the compensation matrix if we're using the GenerateCompensationMatrix script through FIJI. So what we're going to need to do is to crop these images. And so you can crop the images by going to Process, Edit, under the Edit tab, select Crop, and from there you can crop your image. So that's an example right there. So for cropping that image, I just selected the draw rectangle, selected a region of interest by drawing the rectangle, and so this is going to be the end product. And so then I just hit this button here, that's apply, and you can't read it because I have so many channels that it squishes everything together. But if we move things to the right, you can see there's preview, reset, apply. So if you click apply, then you can see it there. And so, and what will happen is now you have your cropped image, and so this image is ready to use for generating the compensation matrix. Now, the other critical thing is you have to have only one image for each color, and they have to be in order. So if BV421 is your first channel, it needs to be the first thing, the first image within this Leica file. So this is what the end product should look like. So for example, you'll have all of your cropped files and your cropped images, one for each color in order. So for me, AF48 is in channel 4, and I have this cropped AF48 image as the fourth image within this Leica file. And so once you have cropped and organized everything as you like, then you can right click on that Leica file, and you can save the experiment and save it wherever you would like. And so now you're ready to go into FIJI and actually generate the compensation matrix. So to do that, click on the FIJI thing, so FIJI will come up. So then you go to File, you go to Open, and here we're going to go to the Chrysalis folder. So the Chrysalis folder is on the desktop, and you want to go to GenerateCompensationMatrix. So here you will find two files. One is the documentation, and one is the actual code, so it's a Python file. So then you want to select the actual Python file, the code, and click Open. So that will run the file. So a lot of stuff will come up. Don't worry about it. It doesn't mean anything. Just click Run. And then when you click Run, you'll first need to select the file. So this new window will come up. First, you select the file that you want to generate the compensation for. So for me, I have this Leica file with the compensation in order, so I'll select that. I want to plot the spectra, save the plot as well, save the SDM. The SDM is the file we'll use for compensation in Chrysalis, and then you can save the CSV as well, which is a nice feature. So then I hit OK. So you'll have this red warning come up. Don't worry about it, as long as you get this graph right here. This script runs really quickly. Now we see that the analysis is complete. So this is what your signal intensity looks like for each channel, for each color. And this is really, so for example, channel 8, this color falls strongest in channel 8 as it should, for example, and this is for channel 7 and so forth, and so that's looking pretty good to me. And if we now go to our desktop, and now we go to this analysis example and the compensation file, so wherever your input compensation Leica file was located, that is where your plot and your compensation matrix will be saved. So now we see that there's this comp in order.lif underscore compensations.sdm file. So this .sdm file is your compensation matrix, and that is what you're going to use within Chrysalis to apply compensation to your image.